Hello, Algebra 2 students. Today we're going to be going over the Unit 9 activity. It's talking about random samples, and we'll be looking at how this activity works. So go ahead and start it up if you haven't already. And let's get started. Let me share my screen here. Okay. So go ahead and go to page 5. It should look like this. It says comparing data. Every year, a pet company sells its food to stores across the nation. Some of these stores are new customers and some are returning customers. For the coming year, the company has set a strategic initiative to increase the proportion of sales to new stores. The sales director is conducting research to determine whether the company's sales representatives need additional training to accomplish the company's goals. Based on experience from the previous year, the sales director has constructed the statistical model shown in the table. This model reflects projections of sales orders from new and current stores from the coming year, broken down by the company's sales regions. So basically what it's looking at is you could see in the Midwest, current stores 85%, new stores 15%. Both these percents should add to 100 across the line, and you could see that. So in the South, you could see fewer current stores, right? More so new stores. And the Northeast, you can see it's kind of similar to the Midwest there. During the first month of the year, the sales director collected data on the sales orders for a random sample of sales representatives within each region. Assume the sales representatives work in only one region. Okay. So then here are the raw numbers here. So in the Midwest, this is for the first month of sales, current stores, new stores. Okay. Consider the first month sales data for the Midwest region. Select the correct answer from each drop-down menu. So we're looking at the first month sales data in the Midwest region. So we're looking at the Midwest region first month sales orders. So you can see from current stores, 362, from new stores, 66. Okay. Let's see. For the Midwest region, the proportion of sales from new stores is approximately, so how much was from new stores? Well, 66 were from new stores, so 66 out of, and we want the total. So the total is these two added together, so 362 plus 66. 362 plus 66. So this is how many stores are from how many are from new stores, and how many total orders. Okay, so how many orders from new stores, how many total orders. So what does this proportion come out to? So this will be 66 over 362 plus 66, 428. And then we want to do 66 divided by 428. And that gives us 0.1542 about. So about 15%. So when you change it to a percent, you move the decimal over twice. So this is 15.42%. Okay. 15. Okay. Because this proportion is blank, the sales director's statistical model, the data is blank with the model. Okay. So here's the sales goals. In the Midwest, he wanted 15% from new stores, and that's what he got. So that's good. So it seems to follow what the model wants. So here, because the proportion is relatively close to the sales director's statistical model, the data is consistent with the model. So he expected from the model 15%, and we got 15.42%. So it's very close to the model, and that's consistent with the model. So for the South region, the proportion of sales is approximately, okay. So for the South region, let's see. So it was 115 from new stores. So for the South, 115 from new stores out of, and then it will be 197 plus 115. Okay, so this will be 115. And whatever I write here, you should probably write on your own on a separate piece of paper or somewhere else. This will help you understand the material much better. So this is 312, just adding these together. So 115 divided by 312. So this is, let's see, right? 0.3686, or in other words, about 36.86%. Okay, moving the decimal over twice, change to percent. Okay, so 36 point whatever, what they were expecting was 26. Okay, so for the South region, we had 30, about 37 if we round to the nearest percent. Because this proportion, oh wait, we're looking for current stores. This is from new stores. So for current stores, it'll be 63. Remember, they need to add to 100%. So I accidentally looked up from new stores, should be from current stores. Okay, so make sure you look, it should be 63 here. But you can get that by doing 100% minus this percent would give you about 63%. But that's not close to what they wanted, right? They wanted 74% from current stores from the model. So this is significantly different from the model. So this is inconsistent with the model. All right. Suppose the pet food company's strategy is to increase the proportion of sales orders from new stores in each region to 25% during the coming year. Consider the data and proportions of sales from the new stores for each region in the first month. Do you think additional training is necessary for all the sales representatives? Why or why not? Okay, so they want at least 25% to come from new stores, Well, we already did in the Midwest, they're only getting 15% from new stores. In the South, it's 36.86%, so about 37% from new stores. What about in the Northeast region? Well, from new stores, it's 60. And the total is 250 plus 60. So 250 plus 60 here. So this is 60 out of 310, which gives 0.1935, about. So about 19.35%. Okay. Now the question said that they want 25% from new stores. So this region and this region, those are the Midwest and Northeast regions. They need to get more training to get the sales up to 25% from new stores. Okay, so they're looking for 25% from new stores. So the South region already met that goal, right? The South is already 36.86% from new stores, but the Midwest and Northeast need their numbers to come up. They need to get those percentages higher. So I want you to explain that there, okay? I want you to explain here in your own words that basically the Midwest and Northeast regions, since they're below 25%, they're going to need additional training in order to increase those percentages up to 25% for new stores. However, the South region does not need additional training in that respect. Okay? So I want you to explain that in your own words as best you can. Okay, I hope that makes sense. But if you have questions, you could always email me. All right, once you're done with that, let's go on to the next page. Make sure everything says unanswered here. Okay. Let's go ahead and read the next section. To meet the company's sales goals, the sales director for the pet food company decided to provide training for some of the sales representatives in the Midwest and Northeast regions. After conducting a 1-month training program, the sales director analyzed the effectiveness of the program by conducting a statistical study. The purpose of the sales director's study is to determine whether attending the training program caused an increase in sales for representatives from the two regions. So the sales director collected sales data from both groups, those receiving training and those receiving no training, for 3 months after the 1-month program, and compared the number of orders secured by those who attended the program with the number of orders secured by those who didn't attend. Okay. So whenever you're gathering data like this, like you're splitting into two groups, right? You're splitting into a group that received training and a group that did not receive training, right? So there's actually a total of 4 groups in a way, right? Because there's the Midwest, there's from the Midwest got training, from the Midwest no training. But then there's also the Northeast, right? So the Northeast people who received training from the Northeast, and Northeast people who did not receive training. So there's basically 4 groups in a way, right? So whenever you're splitting into groups like that, that's what we call an experiment, okay? An experiment. So there's the experimental group, the ones that receive the training, and the control group, the group that doesn't, right? He's not just observing data, and he's not conducting a survey. He's splitting people into groups. So that's an experiment, okay? Because the treatment, so the reason it's experiment is because the treatment was not applied, because the treatment was applied to the sales representatives. This is the best statistical study for the situation because the sales director is trying to establish causality. So he's hoping to see that the training causes better sales for new stores. Okay, suppose there are 1,000 total sales representatives in the Midwest and Northeast regions, with 500 sales reps in each region. Describe the best way for the sales director to include 200 sales representatives with an equal number from each region and an equal number in each group, while yielding valid conclusions in the study. Okay, so he's only going to have 200 sales representatives do the training, okay? And it says we want an equal number from each region. So first off, we want to say that those 200 representatives, we want 100 from the Midwest and 100 from the Northeast, making 200 in total, okay? So let's see. The sales director should get 100 sales reps from the Midwest and 100 sales reps from the Northeast. So he's gathering 100 from each of the regions. Now, when he has the 100 from the Midwest and 100 from the Northeast, he wants to split. He should split those into 2 groups. Okay, so from each region, the sales director should split the 100 sales reps into groups of 50. So he takes that 100, splits into groups of 50. And each of those 50, so one group of that 50 should receive training and one group does not. And then you're going to compare which one does better. Okay. Should split the sales representatives into, I want to add here random groups of 50. So out of the 100, he should randomly pick 50 to get the training, and 50 that do not. Groups of 50 into, let's say, into 2 random groups of 50. One group receives training, while the other does not. This is for both regions, right? So in the Midwest, you have 100 sales rep from the Midwest, 50, a random 50 of those 100 receive training, and a random 50 do not. Okay, same with the Northeast. So 100 Northeast representatives, 50 receive training, 50 do not. And then you're going to compare. Okay. One group of 50 receives training while the other does not. And this is for both regions. In both regions. Okay. I hope this kind of makes sense. Then he should compare the results from the ones that received training to the ones that did not. And the sales director should compare the representatives that received training to those who did not. So that's what he would be looking at. It's like, okay, well, these 50 received training, these 50 did not, and then compare the numbers. So did the training actually make a difference? That's what he's wanting to, the sales director wants to determine. Okay, so looking at 50 that received training, okay, how well did they do? And then the 50 that did not receive training, okay, how well did they do? And is there a big difference, right? So that's important with any sort of training, right? Is the training actually helpful? So that's why you would want to look at, you want at least some people who do not receive training and some that do, so you can compare. If there's no way to compare, then the experiment doesn't work then, right? Because you need a control group, those that do not receive training, and the study group, the ones that did receive training. That goes with any experiment. Okay. For 3 months after the training program, the sales director collected sales data for the 200 sales representatives from the Midwest and Northeast region. The director then broke down the numbers of sales orders for the representatives according to whether they received training or not. The data is shown in the table. Okay, so 3 months sales orders. So from the Midwest, you could see these are the orders from those that received training, and these are the orders from the ones that did not receive training. Similarly with Northeast, those that received training, those that did not. Okay, so use the data shown in the table to complete each statement. Select the correct answer from the drop-down menu. For the Midwest region, the average number of sales orders per representative for the group that had training is, so the group that had training in the Midwest, remember there's 50 in this group. So what we're going to take is this number, 234, and divide by 50. Okay, And that'll tell you how many sales did each representative have on average. So I got 4.68 by doing 234 divided by the 50 who received training. And so the average, oh wait, I should be looking at no training, sorry. For the Midwest region, the average number of sales orders per representative for the group that had training is blank more than, okay. So for this, for those that received training in the Midwest, they had 4.68 per representative. So 4.68 per representative that received training in the Midwest. What about those that did not receive training in the Midwest? So again, I would take the 196 here and divide by 50. So the average sales for those that did not receive training was 3.92. So I want to know the difference there. So that means I'm going to subtract because it says how much more than. Okay, so let's go ahead and subtract that. Okay, so that's 0.76. So the average representative that received training had 0.76 more sales. Okay, that's significant. Okay, I want you to do the same for the Northeast. Okay, so take the 252 divide by 50, take the 178 divide by 50, and then subtract those and figure out what the difference there is. Okay. And as you could see, this was a significant increase, right? Like these numbers are quite a bit bigger than these, right? So the ones that received training performed much better than those that did not. So the data from the sales director study indicates that the 1 month training program increases sales. Right? It's hard to argue that, right? This is a pretty substantial increase over these. Okay, and that's it. Okay. Finalize and submit for grading. Okay, well, I hope that made sense. If you have any questions, feel free to email me. My email, ttrigg@ofy.org. And I hope that made sense. All right, and I will see you next time with the Unit 10 activity.